Hello friends, myself Rajendra Mahajan presenting my video on Fourier series. Example, find Fourier series for function f of x is equals to 0, range minus pi less than or equal to x less than or equal to 0, and the second value is pi by 4 times x for the range 0 less than or equal to x less than or equal to pi. The first step is to get the value of L. Comparing the range with C to C plus 2L. Here's the value of C is minus pi and upper limit C plus 2L is pi. Substituting the value of C as minus pi, we get 2L as pi plus pi means 2 pi, and therefore dividing by 2 we get the value of L as pi. This is the first step. Watch the video up to end for clear understanding. If you observe the terms, the range is minus pi to plus pi, means we can check the function for even or odd, but this function is neither even nor odd due to the value, one of the value of the function as 0. The function is neither even nor odd, means we have to go for full range Fourier series. That full range Fourier series is given by the formula is like this: f of x is equals to a0 by 2 plus summation of an cos of n pi x divided by capital L. N changes from 1 to infinity. And second, summation of bn into sin n pi x by L. Again n changes from 1 to infinity, and we call this as equation 1, where first Fourier coefficient is a0, given by formula is 1 by L integration from C to C plus 2L of f of x and its integration with respect to x. Substituting the value of L and that limits 1 by pi minus pi to pi integration of f of x dx. Splitting that integral as minus pi to 0 and 0 to pi. In between minus pi to 0 value is 0, and between 0 to pi value is pi by 4 times x and its integration with respect to x. First term is 0, and therefore integration of second is 1 by pi as it is, taking pi by 4 outside the integration sign. Integration of x is x square by 2 and limit from 0 to pi. Pi get cancelled, we get 1 by 4 times, substituting the upper limit we have pi square by 2 minus lower limit at 0, and therefore value for a0 is pi square by 8. We call this equation number 2. Then we have to obtain the second coefficient, that is an, Fourier coefficient. Formula is 1 by L integration from C to C plus 2L f of x cos of n pi x divided by capital L and its integration with respect to x. Substituting the value 1 by pi integration from minus pi to pi f of x cos of n pi x upon pi get cancelled, we get cos of nx only. And then splitting that integral 1 by pi as it is, minus pi to 0 value is 0 for the function, and plus from 0 to pi value is pi by 4 times x cos of n pi x by pi means cos of nx only. Pi by 4 we take outside. integration of here that term is pi by 4 times x, a small correction, and therefore the remaining terms are integration of x into cos of nx between limits 0 to pi. A product of two terms, therefore we have to integrate it by generalized part. X means algebraic, cos means trigonometric. Therefore x must be the first and cos must be the second term as per LIATE rule. Therefore pi get cancelled, we get 1 by 4. First term x, integration of second term, integration of cos is sin nx by n minus derivative of first term is 1. Next integration of sin is minus cos nx by n square. Next derivative 0, therefore we stop here and limit from 0 to pi. Substituting upper and lower limit, we have the term sin n pi value is 0, cos n pi value is minus 1 raised to n, sin 0 is 0 and cos 0 is 1. Therefore these four values we have to use. Therefore 1 by 4 as it is. Sin n pi 0, therefore first term becomes 0, minus minus it becomes plus, cos n pi is minus 1 raised to n divided by n square, minus for lower limit x is 0, 0, cos 0 is 1, therefore 1 by n square. From these two terms we can take 1 by n square common. Remaining terms are minus 1 raised to n and minus 1. And whenever we have such type of term, we have to find two values, what is for even and what is for odd. When it is even, its value is 1, 1 minus 1, we get 0 for even, and for odd we get minus 2 upon 4n square, means minus 1 by 2n square if n is odd. Means while substituting it in equation 1, we have to replace n by its general term. General term for odd is 2n minus 1. Then bn is given by 1 by L integration from c to c plus 2L f of x sin n pi x by pi L and its integration with respect to x. Substituting values, we get 1 by pi integration from minus pi to pi f of x into sin of nx, as pi get cancelled. Then splitting it as per the previous calculation, it is integration from minus pi to 0, value is 0, and integration from 0 to pi, value is pi by 4 times x into sin of nx. Go step by step, though it is lengthy, very easy calculations. Therefore 1 by 4 as it is, no change. Integration from 0 to pi of x sin of nx. Again integrating it by generalized part as it is a product. X must be the first and sin must be the second term. 1 by 4 as it is, no change. First term x, integration of sin is minus cos nx upon n, then minus a derivative of x is 1, and next integration of cos is sin, but with that minus sign, therefore it becomes minus sin nx by n square. Next derivative 0, we stop here, limit from 0 to pi. Again that same four values, sin n pi 0, cos n pi has minus 1 raised to n, sin 0 0, and cos 0 is 1. I am giving these values as a supporting statement. When we put x as pi, it is minus pi, cos n pi is minus 1 raised to n by n, sin n pi 0, second term becomes 0, minus lower limit x 0 0 and sin n pi is 0. We have minus pi upon 4 minus 1 raised to n by n. This is the value of bn, equation number 3rd. an we call as equation number 2 or 3, and this is as equation number 4. This is equation number 4. Then substituting all these values of a0, an and bn in equation 1 to obtain the required Fourier series. As fx is not having one value, we are not able to substitute any value. Therefore, we keep fx as it is. a0 is pi square by 8 divided by 2. Summation of from n equal to 1 to infinity. Value exists for odd, and therefore while substituting it, we have to replace it n by 2n minus 1. We have minus 1 by 2 times n square means 2n minus 1 whole square, replacing n by 2n minus 1. And again cos of 2n minus 1 times x. Everywhere we have to replace n by 2n minus 1. And in bn, the value is minus pi by 4 minus 1 raised to n divided by n into sine of nx. And this is the required Fourier series. We simplify it again. Pi square by 16 minus 1 by 2 we take outside. Summation from 1 to infinity of cos of 2n minus 1 times x divided by 2n minus 1 whole square. Minus pi by 4 outside. Summation of minus 1 raised to n sine of nx upon n, a required Fourier series of that given function. And this is a full range Fourier series. Therefore, I have explained various step by step. Every step I have explained. Please like, share it, as well as subscribe to my channel. And to receive the notification, please press the bell icon. Thank you. Thanks for watching.